I'm Ling Huang from the Psychology Department, and I'm honored to have this opportunity to share with you the course on psychology and educational statistics. And I have a strong interest in psychology and education statistics, and I hope that through my presentation I can share the importance and the profound insights of this topic. In the first part, I want to talk you about the importance of statistics and in our lives. Statistics is everywhere. It's not just a subject we study in school, but something we incur every day. Let's take a look at election. When we vote, we rely on statistics to understand trends, predict outcomes, and make informed decisions. Polls and surveys use statistical methods to gather and analyze data, helping us understand public opinion and make sense of the political landscapes. Now let's talk about the product sale analysis. Companies use statistics to analyze sales data, identify patterns, and make strategy decisions. By examining factors like consumer behavior, marketing trends, and demographic information, they can optimize their marketing strategy and improve their products. In our personal lives, we incur statistics regularly, from interpreting medical test results to analyzing sport performance. Whether we realize it or not, statistics play a crucial role in shaping our understanding of the world around us. So, all of the examples above illustrate what statistics is. First step in statistics is collecting data. This involves gathering information through surveys, experiments, or observations. Once we have the data, we move on to the next step, analyzing it. Here we use various statistical methods to organize, summarize, and interpret the information. After analyzing the data, we draw conclusions based on our findings. This is where we make sense of the patterns and the relationship we have uncovered. Finally, we use these conclusions to make appropriate decisions. Whether it's on business, healthcare, or social science, statistics help us make informed choices that can lead to positive outcomes. Statistics also has another important feature. Due to limited resources, we cannot collect data from every single individual in the world. Therefore, we sample from the population and use the sample to estimate characteristics of the population. This approach is more efficient. Statistics is crucial in analyzing and interpreting data from psychology studies, whether it's understanding the effectiveness of therapy interventions or examining the relationship between variables like stress and performance. By using statistics methods, psychologists can draw meaningful conclusions and make informed decisions that contribute to our understanding of human behavior and mental processes. For example, in the process of analyzing data, it is important to consider the characteristics of the experiment, choose different statistical methods, and determine how small the probability needs to be in order to detect significant differences and reject the known hypotheses. These are all aspects that statistics can help explain. In education, statistics help analyzing students' performance, evaluate teaching methods, and identify areas for improvement. By using statistics, educators can make data-driven decisions to enhance learning outcomes and tailor instruction to individual student needs. Understanding and applying statistics in education is crucial for creating effective teaching strategy and furthering student success. The next session is an introduction to common terms in Part 2. Descriptive statistics is a branch of statistics that involves organizing, summarizing, and presenting data in a meaningful way. It helps us understand the basic features of the data set. Some common descriptive statistics include measures of central trends such as the mean, median, and the mode, which tell us about the typical or average value in the data. Other descriptive statistics include measures of variability such as the range, variance, and standard deviations, which tell us how spread out the data is. Statistics allow us to have a basic, quick understanding of the data. The first term to introduce is measure of variance. It provides insight into how spread out the data is within a data set. They help us understand the degree of variability among the data points. Common measures of variation include the range, which the difference between the highest and the lowest value, and the standard deviations, which quantifies the average distance of data points from the mean. These measures are essential for understanding the distribution and the reliability of data. The best example that you have learned is a box palette. It is a graphical representation of the distribution of the data set. The sum of square deviation from the mean is a measure used to quantify the variability or dispersion of a data set. It involves calculating the square differences between each data point and the mean, then summing up these square differences. This sum provides insights into how spread out the data is around the mean. The formula for the sum of squares from the mean is this, where sigma represents the summation symbolic, xi represents each individual data point, x bar represents the mean of data sets. It is similar to the regression line you learned in high school, except there was two-dimensional. Each point square's vertical distance to the line was added up, but with SS, it is one-dimensional. You just calculate the sum of the square distance from each point to the mean. Variation in statistics refers to the degree of dispersion or separate within a data set. It helps us understand the context to which data points differ from each other and from the central tendency, such as the mean or median. High variation indicates that data points are separated out widely, while low variation suggests that data points are closing around the central value. Here you can notice there are two formulas, the sample variation and the population variation. You can see that the numerator in both formulas is SS. The only differences between them lies in the denominators used in their formulas. For sample variation, we divide it by n subtract 1, where n is the number of data points in the sample. This correction factor is used to provide an biased estimate of the population variance from the sample variance. On the other hand, for population variance, we divide by n, which n is the total number of data points in the population. In summary, sample variation is typically used when working with a subset of data from a larger population, while population variance is used when working with data from the entire population. Standard deviation is a measure of the dispersion or spread of a dataset. It qualifies how much individual data points deviate from the mean. A higher standard deviation indicates greater variability among data points, while a lower standard deviation suggests that the data points are closer to the mean. It is calculated by taking the square root of the variance, which is the average of the square difference between each data point and the mean. Standard deviation is widely used in statistics to understand the distribution of data and making comparisons between different data sets. When looking at sample variation and sample standard deviation, you will notice it is divided by n subtract 1. But why n subtract 1 and not n subtract 2, subtract 3, and so on? Well, this is where the concept of degrees of freedom comes into play, which is crucial in statistics. Degrees of freedom represent the number of independent values or quantities that can vary within a statistical calculation. In simple terms, it is the number of variations in the final calculation of a statistics that are free to vary. For example, in a sample mean calculation, if we know the mean of the data and the value of all but 1 point, then the remaining data points has 1 degree of freedom to vary. So I can answer the question above. We adjust the denominators of the sample standard deviation to n subtract 1 in order to correct it, making the sample standard deviation an unbiased estimator of the population. An unbiased estimate of the population is a statistic that, on average, provides an accurate estimate of a population parameter. In other words, when we repeatedly sample from the population and calculate the estimate, expected value equals the true population parameter. Next, let's do a simple set of questions. The scenario is that there is a class and we know the scores of 5 students, which are 8, 9, 11, 7, and 5. We want to ask for their mean, sum of square deviation from the mean, sample variation, sample standard deviation, and degrees of freedom. Before we start the calculation, let's clarify that the data of these 5 students are sampled from the population. It is a class. That's why the question asks us to calculate sample variance and the sample standard deviation. Next, we can proceed to our first step. It is to calculate the mean, which will facilitate the subsequent calculations. So it is 8 plus 9 plus 11 plus 7 plus 5 divided by the number of 5, which gives us a mean of 8. The second step is to calculate the sum of square deviation from the mean. So we subtract the mean from each number, square the result. For example, 8 subtract 8 equals 0, and 0 squared is still 0. Then we sum up all these square differences to get the sum of square. It is 20. The third step is to divide SS by the denominator n subtract 1 to obtain the sample variance. So we divided 20 by 4 to get the sample variation equal to 5. The first The fourth step is to take the square root of the sample variance, which gives us the square root of 5 equal to the sample standard deviation. Finally, we calculate the degrees of freedom, which is simple the number of observations, 5, subtract 1 equal to 4. The above is our simple set of questions. Feel free to practice more. The last part is quick Q&A. Statistics feel useless. Statistics are far from useless. They are essential for understanding data, making informed decisions, and solving real-world problems. Do I need to be good at statistics and math? Yes, statistics and math are essential skills. They are crucial for analyzing data, solving problems, and making informed decisions in various fields. Will statistics work be replaced by AI? No, statistical work won't be replaced by AI. AI complements statistics methods, but human expertise is still crucial for interpreting results and making decisions. Thank you all for listening. That includes our bridge class on psychology and education statistics. I hope you've gained some insights and developed a greater interest in statistics.